Hi, everyone. Okay, before I get into the lesson, the mini lesson we're going to do today, I just want to go over a couple of things. Make sure that for yesterday's assignment, if you weren't able to go on Power School, I know you can't see your quarter grade, but most students were able to go on and find their individual quiz score. I think you can go into recent grades. If you are unable to do that, please just email me so that I can send you what your quiz score was and what you lost points on. I did type this up in the comments of the grades, but if you were unable to see that yesterday, what I would like you to do is email me. Make that the first thing you do in class today, and then I can send you back that information so that you can complete the quiz reflection. This is not ideal. Obviously, the week leading up to grades being due, my son is still sick, so I have to stay home with him again today. So the plan will be, I'm going to go over a brief new topic with you. It's quick. I'll go over a couple questions. You don't even need notes. Just try to follow along with the very short video. And then I'm going to give you a Delta Math check-in, which will be 5 questions that are just like what we're about to do, and you'll complete that. Okay, you can even complete it, by the end of the day if you don't have time to finish it during the period. But I suspect that you'll have time for that. If you have any questions, email me, and I will definitely be in tomorrow. So for those of you that took the quiz late, maybe after school on Friday, or if you took it as a makeup, maybe yesterday or even today, I will be in tomorrow. I will grade those quizzes. I will give them back to you, and you can work on the reflection tomorrow. Okay, let's get into it. So we're still in our trig unit. We're moving into a topic called identities and simplifying with trig identities. So the identities that are right on this page shouldn't be new, right? These are the ones that we've been working with. The quotient identities, the fact that tangent is sine over cosine, cotangent is cosine over sine. Mostly we'll be using these 4. The reciprocal, that cosecant is 1 over sine and secant is 1 over cosine. Not to say there would never be a reason for the cotangent is 1 over tangent, but typically the way we answer these questions is to try to simplify and get everything in terms of sine and cosine to reduce to simplest form. So I'll show you what I mean. If you look at number 1, again, the goal of this one is to write it as a single trig function. So when I look at question number 1, I can see I have cosecant times cosine, this expression. So I'm going to remind myself here, and you can even look back here, cosecant, right, is just 1 over sine. So I'm going to replace cosecant with that, and I'm going to say 1 over sine times cosine. And I'll even maybe put cosine over 1, so it looks like a fraction times a fraction. Remember, with fractions, you multiply the top, you multiply the bottom, right? So now I'm going to have cosine over sine. Well, that should look familiar because cosine over sine, this is really what? Cotangent. So if I have to write this as a single trig function, this whole thing simplified to just be the cotangent of the angle. So we started by replacing cosecant with 1 over sine. We multiplied. We recognized that that also is an identity that's equal to, in this case, cotangent. Okay, let's look at the next one. And just remember, when you are looking at these questions to simplify, if the function is raised to a higher power, so let's say I had, like in this one, secant squared is the same as like 1 over cosine squared. So the relationship is still there, that secant is 1 over cosine. If it's squared, then it's just 1 over cosine squared. And the same would be true about all of these. Like if you had tangent squared, you could say that that's really like sine squared over cosine squared. Okay, so let's try number 2. So we have secant squared, so I'm going to replace that one. Again, we know that secant squared, or secant in general, is equal to cosine when you flip it. So 1 over cosine, so I'm going to replace that one. 1 over cosine squared. I'm going to leave sine. I'm just going to put it over 1 so it looks like a fraction. And then cotangent, we just used this one before too. In our answer, cotangent is cosine over sine. So let's write that. So if I multiply everything in the top, I have 1 times sine times cosine. So I just have sine times cosine. And then in the bottom, I have cosine squared times 1 times sine. So if I have a factor dividing into itself, that should cancel out. So sine and sine just cancel the 1. And then, not that you need to write this, but you end up with cosine, 1 factor of cosine over 2 factors of cosine. Think of this like x over x squared. You would end up with just 1x in the bottom if you subtract it either from the bottom, or think of it as like you have 1x over 2x's, 1 set cancels. If you can't, you can't write nothing in the numerator. If everything cancels, you'd have to write what's still there, a factor of 1, and you would get 1 over x. So that's what's going to happen here. We're going to end up with one of these cosines. We could even write it like that if we want. Cosine times cosine. One of these cosines cancels. 1 is still remaining, and it's in the denominator. And then what is 1 over cosine? We should recognize this is secant. So this whole simplification brought us full circle back to one single trig function, the secant of an angle. Okay, let's try number 3. So for number 3, I'm just going to zoom in a little. Secant, we know, is 1 over cosine. So again, the best way to start any of these is how can I write this function in terms of sine or cosine? So if it's secant, or if it's cosecant, or if it's tangent or cotangent, you're going to want to take that moment and write it in terms of sine or cosine. Okay, now I have a complex fraction. So what I'm going to do is remind myself, we're going to keep, we're going to change, right? We're going to flip. So I'm going to remind myself that here I have 1 over cosine being divided by 1 over sine. So I'm going to multiply it by the reciprocal, right? So keep the top fraction, change it to multiplication, multiply by the flip or the reciprocal of the denominator, and you get sine over cosine, which we should recognize is tangent. And let's just try one more. Okay, so for this question, we have the sine of an angle y times the secant of that same angle minus the cosecant. So we might start, let's say, we'll start by replacing in terms of sine and cosine. So secant is 1 over cosine. Cosecant is 1 over sine. I'm going to put this sine over 1. And then we're going to distribute, right? Because it's telling us it's in front of a parenthesis. That's typically what we would do. So you get sine of y over cosine of y minus sine of y over sine of y. Sine over cosine is tangent. And then sine over itself is just 1, so tangent minus 1. So what I want you to do is to, if you need to rewatch this, you can, but you're going to go on to Delta Math. There's an assignment. It says today's date. It says 2 points for simplifying trig expressions, or I think that's how I titled it, simplifying trig expressions. It's 5 questions. You're going to use the identities that are up here. So these are, in your packet from last unit, or you can just leave this video open if it helps. And you're going to simplify. And Delta Math will tell you if it wants it a certain way. And let me know if you have any questions. I just want everyone to practice this, and tomorrow we'll continue going through this lesson and I'll hand out the new packets. All right, everybody, thank you for attempting this. And again, let me know if you have any questions. Have a good day.